The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechVic webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Ways to Succeed with Hadoop in 2015. Our guest speaker today is Tejas Sarvana. He is a Hadoop SME at Edureka. Tejas is a trainer and developer on Hadoop ecosystem and Java J2E technologies. He has 18 plus years of experience and has worked on developing many web-based products and projects using J2E. He's currently working with Edureka as a consultant. He's also associated with Levin Software, a product development company at Bangalore. Currently working on distributed data mining in sensor networks and managing projects on event processing in sensor streams. Also involved in fleet tracking system by using OpenGTS, that is Open GPS tracking system. So OpenGTS is the first available open source project designed specifically to provide web-based GPS tracking services for a fleet of vehicles. Also involved in building team on Apache Hadoop. So without further delay, I introduce you all to our guest speaker. Over to you, Tejas.
Thank you. Hello friends, this is Tejas here. I am from Bangalore. I hope all of you can hear me well and see my screen. So welcome to Hadoop in 2015. I will be taking you through this session, so sponsored by edureka.in, Edureka, right? So let us start with the session straight away without wasting time. So objectives of this session, right? If you see, today we will see how can we use Hadoop like a Swiss knife. That means to do multiple jobs we'll discuss, right? So look at some of the quick growing open source communities like Spark, Cassandra, Pentaho in this big data space, right? So, and also we'll discuss some of the real-time scenarios, I mean use cases where we have to move really, we need to look at real-time processing the data. And one more important architecture, that is Lambda, which is picking up slowly, we will also discuss, and we will discuss about new upcoming tools and products, right? So if time permits, I will also show you how this Spark is fast. I have installed Spark and Hadoop in my virtual machine here and my desktop. So if time permits, I will definitely love to do that. And I also have Spring integration with Hadoop. Probably Springers, that is Spring developers would love to look at that. That is the reason, because I have seen a lot of Java developers still not started looking at Hadoop. So what is advantage of Hadoop and then how Hadoop is moving, let us see. Probably if time permits, I will also show you how to integrate a Spring application to Hadoop with a simple example, right? So let us start. So Hadoop in 2015 is the discussion, right? So we have come a long way as far as Hadoop is concerned. We have Hadoop Gen 1, we have Hadoop Gen 2, right? If you see 2014, right, all the companies, they have slowly started migrating to Hadoop 1 to Hadoop 2. When I say Hadoop 1, 2, they are platform. I mean, Hadoop generation itself, Hadoop generation 1, generation 2. When we started in our company almost 3.5 years back, we started working on Hadoop generation 1. Though we expected a lot of things from Hadoop, right? Result was continuous innovations on Hadoop itself. So resulting Hadoop 2. So slowly in this year, we could able to see all the companies started moving towards Hadoop 2. So what is Hadoop 2? Basically, Gen 1 had a lot of limitations in terms of name node, single namespace, and a single point of failure, and then processing environment only restricted to batch processing, right? So Hadoop 2 basically looked at overcoming all these problems. Single namespace was solved by federation in Hadoop 2. High availability solved the single point of failure of Gen 1. And single processing environment, that is MapReduce, again solved by Yarn, yet another resource negotiator, right? So when we see Hadoop 2, it is not only now MR, right? So we have lot of processing environment, processing frameworks, we can say, built on top of Hadoop data now. Interactive days, we call it as, which is low latency dispatch, which gives low latency dispatch. Storm, which is a large scale live event processing implementation, again originated by Twitter, right? So processing environment means a lot of processing environment is supported in Hadoop 2, that's what I mean to say, whether it is streaming, graph processing, message passing interface, parallel processing, right? Massive parallel processing, MPP. So Hadoop 2 raised to give a chance for a lot of other processing environments, right? So now with that, there are a lot of tools, and then other processing environment itself joined this, and then they have started integrating with Hadoop. So as we go ahead, we will see now one by one, right? Today, we all know what is big data and how Hadoop software helps in structuring this big data and makes it suitable for data mining, analysis, right? Let's see some of the Hadoop predictions for 2015, right? So to talk about growth rate itself, over the next 5 years, Hadoop market is expected to grow 2.2 billion. That is a compound annual growth rate of 58% according to marketanalysis.com, right? So there will be a strong demand, right, for Hadoop to become real-time and transitional, we say, to become alternative for traditional database vendors like Oracle, MySQL, right? So Hadoop will continue to extend its toolset to provide viable alternatives for traditional RDBMS, MPP databases, ETL tools, database warehouses, right? So this year, it is proved that every company is in the business of data, building the demand for cost-effective and scalable big data platform. As a part of this hype, we expect to see more Hadoop-related acquisitions, IPOs, and the rise of new jobs in 2015. When I say product development around Hadoop, so we will witness a rise in the importance of enterprise Java developers also, right? And as far as NoSQL with Hadoop is concerned, will graduate from mostly experimental pilots, right? So though till now to standard components of enterprise management, we will see coming years. Right. So though we saw off-baked projects than success in 2000 till now. So but in 2015, right, these enterprises will and have to focus on specific problems and find the right solutions. We all hope that's what will happen. Right. So big data movement will generate 4.4 billion new IT jobs by 2015. Right, and we all know SQL, right? So companies will demand SQL for all reasons. From now onwards, definitely you will see SQL, the data querying language tool used by application developers, will become one of the most prolific use cases in Hadoop ecosystem, definitely, right? So there will be a demand that big data SQL works just like full-fledged modern SQL that developer already use, right? That's what is expected. So as far as ETL tools are concerned, right, when we see new in-memory streaming technologies that change the rate at which we act on data, so this will cause transformation in ETL tool itself. This will definitely, that is in-memory streaming technologies, right? This will cause a transform in ETL tool itself, the way they work, right? To support interactive exploration of data and creating new data combinations on the fly, we need to take advantage of definitely distributed in-memory processing, right? That is one of the biggest predictions of 2015, right? But last but not the least, security and governance will also increase big data innovations, right? In addition to access, authentication, authorization, and auditing, we may extend modern security practices such as data masking, detection to the big data environment, right? So, as I said, Gen 1 or Gen 2 Hadoop, we started looking at Hadoop for multiple purposes. For me, whenever I go for presentations and then questionnaires, it looked like we were using only one single screwdriver for thousands of types of screws. But nowadays, if after Hadoop 2 and then integration of all these tools and technologies, definitely we feel Hadoop can be used as a multi-purpose tool, right? In fact, almost 3.5 years back when we started looking in our company, right? So when we started looking at Hadoop, almost 6 months, we just used Hadoop as a data source because it was very much cost effective. We just used to move data to Hadoop and then save it. Maybe after more than 6 months, we didn't actually process that itself. Nowadays, if you see, we have all these integrations, tools supporting Hadoop, right? Mahout, basically a machine learning tool itself as integration with Hadoop, right? So nowadays, latest Mahout, if you see, it was working on MapReduce environment, but it was batch processing. So now it is again uses Spark kind of a real-time environment, Mahout. Mahout supports three major, categories like recommendations, classifications, clustering, right? Machine learning tools. Cassandra, it is just for this figure, we have just added one, but there are, if you see multiples of NoSQL itself we have, right? HBase, HBase is closely integrated with the Hadoop itself. HBase is also a NoSQL database. Again, there are a lot of improvements as far as HBase is concerned, right? R analytics, again, we can integrate to Hadoop. We can use Python code itself. When we started, almost I'm talking of around 3 years back, we thought only streaming, we can just use streaming using Python, right? So all others processing was supposed to be on Java. Nowadays, everything is changing. In fact, there are a lot of developments going on to not to write program itself, right? Just GUI based queries is what you will see by later, by nearly coming very near, right? That is one of the Pentaho's much effort. You will see lot. You will avoid a lot of programming itself, I meant to say, right? So Hadoop can be integrated with multiple analytic tools to get a best out of it, like machine learning, R, Python, Spark, MongoDB, right? MongoDB, again, one of the newest databases, right? So now, as I said, let's look at some of the quick growing open source communities in big data. No doubt it is Spark, right? Spark is a powerful open source processing engine for Hadoop data. It has quickly become one of the largest open source communities in big data, right? With more than 200 contributions, that too from 50 plus organizations. Whenever you hear Spark, nothing but it is speed, right? Spark enables applications in Hadoop clusters to run 100 times faster. That is the advantage because it is in-memory processing, right? So it runs 100 times faster in memory and also 10 times faster even when it is running on disk. That is the power of Spark, right? Addition to simple MapReduce, right, environment, what we had, batch processing we call it as, right? So addition to this, it supports SQL queries. It supports streaming of data. It supports complex analytics such as machine learning and graph algorithms, right? On top of this, user can combine all these various capabilities in a single workflow. That is the beauty of Spark. In a single workflow, you can we can combine all those capabilities which I have mentioned. Right? So Spark can be used along with Hadoop too. When I say that Spark built on Hadoop storage, that means Spark is 100% compatible with the HDFS, HBase, and Hadoop storage system itself. So your data is immediately usable in Spark. Advantage, speed, right? So we can say in three manner, that is Spark directly working on HDFS, Spark again on Yarn or Mesos on top of HDFS, Spark using Yarn itself again, and third one, we also have out of the box support for Spark inside MapReduce. We call it as SIMR, Spark inside MapReduce. That is also possible. If you want to, I mean to say, if you want to configure Spark on top of directly HDFS, that's what we have done. I have done now in my virtual machine. Spark directly runs on my HDFS. It doesn't use Yarn. That is one configuration. And you can also run Spark on top of Yarn, right, for processing HDFS data. And probably you want to use MapReduce itself. That is also possible. All these three ways are possible. Right, so Spark can use as the cluster resource manager in Spark. Sorry, Spark can use Yarn itself as the cluster resource manager in Spark, right? Yarn mode. That is also possible. So as a different build for Yarn specification integration, this is what I was mentioning, right? Spark as a different build on Yarn. So Yarn spawns the Spark program as Yarn process itself, where when we say yet another resource locator, I hope all of you know, we have multiple daemons itself, resource manager, right, node manager, and one per application, app master, right? All these daemons coordinate in terms of Yarn processing, right? So when I say one per app master, so one per application, one that is app master. So that means each application, right, or process or program, you can say job, you can say one app master will be taken care. App master will be assigned to it, right? So here also where in terms of Spark also where app master process is actually the driver program and Yarn child processors are Spark workers, right? So basically, if you see Spark, right, it is based on two key concepts. We call it as RDD, DAG. RDD is nothing but RDD, resilient distributed data sets, RDDs. RDDs supports two kinds of operations. One is transformations, actions. When I say that two kinds, I hope all of you can remember normal traditional MapReduce, right? So these transformations almost like create new data sets from input and works like mappers, and actions, right? So return value after calculation on the data sets like reducer. That is this resilient distributed data sets, that is RDDs, right? And one more key concept of Spark is DAG, direct acyclic graphs, which plays a very important role in eliminating this MapReduce multi-stage execution model, right? Because of this multi-stage execution model, it can it eliminates this. It can give good performance and performance improvements. DAGs, right? So now on lower volumes of data per node, launching Spark without Yarn yields better results. When I say this, if you have small volumes of data, you don't even have to look at Yarn. You can directly run Spark, which will yield good results, right? Spark core, we call it as. So in this diagram, this you can take it as in general data platform, bottom layer. you can take it. It's not only MR, you can use anything here, right? So in general, you can use any data platform here, right? So this is Apache, Hadoop, and OSS ecosystem. You see all these highlighted components, dark blue color, are Spark components. We say Spark core, that is, it's a general execution engine which supports all these things. Spark core. It provides in-memory computing capabilities to deliver speed, right? So now, and also it supports wide variety of applications itself, whether it is Java, Scala, Python. API is very simple here using Spark, right? Now, Shark, I hope all of you might have heard, right? Spark plus Hive, we can say, Shark, right? So nowadays, Shark is slowly getting replaced by Spark SQL. Spark SQL, right? So this is the engine for Hive data, Hive data that enables unmodified Hive queries to run 100 times faster. Can you imagine? Right? So Hive queries, same Hive queries without any modification, you can run 100 times faster. And you can easily integrate SQL query processing with machine learning. Great, right? So now Spark streaming enables, that is, this streaming enables powerful interaction of analytic applications across both streaming and historical data, right? So MLlib, what is MLlib? That is machine learning library itself. This is a scalable machine learning library that delivers high quality algorithms with advantage is 100 times faster in speed, right? So the library can be used in Java, Scala, Python. That is the value added, right? So now when we say GraphX, right? If you see data flowing from social media networks, maybe targeted advertising or astrophysics, anything you take, we capture data in graph structure for processing machine learning and data mining, right? So it is not easy in a traditional processing environment like MapReduce, BatchPay. It is not easy, right? It is really difficult. So GraphX enables to interactively build, transform, and execute graph algorithms, right? And also we have Spark R. I hope we don't have it here in the diagram. That is a package for R statistical language itself that enables R users to leverage Spark functionality. That to interactively from within the R shell itself. That is the beauty. Now, when you see these much features, again we can think Spark itself as a Swiss knife on Hadoop, right? Again, it does multiple jobs. We can say like that, right? So because of this combination, this marriage is very, very important. That's what we feel, right? Spark plus Hadoop marriage is very important, right? We don't have to check horoscopes with any pundits for this marriage, right? So now combination of Hadoop and Spark, if you see this red colors, right, are all Hadoop, and this blue, if you see, we are talking about Spark, right? Unlimited scale Hadoop, we all know, right? Multiple data sources, multiple applications, multiple users. That is unlimited scale. Compared to this ease of development, again, this is Apache, right? As I said, easier APIs where we can integrate Python, Java, Scala, and built in more than 80 plus high-level operators we have. We use it with shell, right? We can use it with shell. So that's where we say ease of development, right? So now let us look at enterprise platform. That is, again, as I said, Hadoop, right? We can now, by Yarn, introducing by Yarn, we say now we can rely on it, right? There is nothing single point of failure, I can say, right? Reliability you can have, right? And with the help of schedulers, right, we can manage multi-tenancy. That is one of the need for enterprise platform, right? Security, right? All this is taken care by Hadoop nowadays, right? Enterprise platform need. And as I said, in-memory performance, again, RDDs, DAGs, right, which will unify processing, right? So as I said, this DAG, right, so it eliminates MapReduce multi-stage execution model for better performance, right? And RDDs as two operations, as I said, like transactions, actions, right? And combined workflow, Shark, machine learning libraries, streaming facilities, graphics, right? And here in Hadoop, we say wide range of applications on different kinds of data itself. Directly, Hadoop is a distributed file system, we all know, right? So files itself will be managed, any kind of files, be it be just simple TSV files, CSV files, tab separated values, that's what, JSON, XML, anything, audio files, video files, we just move it onto Hadoop to process, right? Semi-structured, unstructured, and databases itself we are building around this. Right? With this combination, you will see any kind of advanced development can be achieved, right? That too with unlimited on any kind of data, any volume of data, right? So if Shark uses Hadoop as a storage only, Shark, okay, as I said, Shark can use Hadoop as a storage. Shark can use Hadoop as storage as well as cluster manager, right? Right. So SDFS provides distributed storage of large data sets. What is one of the main components of Hadoop? One is SDFS and other is processing framework, YARN, right? So SDFS takes care of reading, writing of the files, and that too, it splits the data across network, right? Any volume of data, it just based on blocks, default block size, it distributes across the network. High availability is assured natively through SDFS because based on default replication factor, if you see, it also replicates the blocks data and distributes to separate nodes. That means each replication of a particular block will always be stored in a different machines, different nodes, right? And beauty is no extra software installation is required. No extra software installation is required. And Spark is compatible with Hadoop 1, Hadoop 2. As I said, we can use it as a three usage, right? So one with the help of SIMR, that is Spark inside MapReduce itself, you can run one Spark you can run on Hadoop directly, and Spark we can run on YARN also. And the Spark can rely on SDFS for data loss during the computations. Right? Using Spark as an execution engine. Right? So I told you now, one, you can use Spark inside MapReduce or Spark directly on SDFS and or Spark on YARN itself. Spark can be integrated with YARN for its execution. Spark can be used with other engines also, Mesos, cluster managers, right? Spark integration automatically provides processing scalability. Sorry, YARN integration automatically provides processing scalability to Spark. And Spark needs also YARN, that is 2+ versions, in order to use it for execution. Or you want to see real good results, so 2+ is advisable. Right? Every node in Hadoop cluster need Spark has to be installed. One is the prerequisite, and using Hadoop cluster for Spark process requires RAM to be upgraded. One of the major company where I worked, you can see 128 GB of RAM used for this marriage. Again, Spark running with Hadoop, right? 128 GB on each per node, I mean to say, RAM. So the integration distribution of Spark is quite new and still the process are still in the process of stabilization. Definitely you will see in the coming years, right? 2015, you will definitely see some good improvements, right? So big data, we just store it onto Hadoop, right? So this is the basic need, right? So complexity is today's data comes from multiple sources. The real issue is not that we are acquiring large amounts of data. It's what you do with the data itself, right? We need to analyze it to find answers, not many answers, like cost reductions, time reductions, new product development with optimized offerings, right? Smarter and quick business decision making, you need to process the data. By combining this big data and high-powered analytics, it is possible to determine root cause of failures, issues, and defects in real, maybe we say near real time, right? So we can take advantage of just move the data, then do live streaming with Spark and process, and then show the results, right? This may be the accepted way. This just I have taken from executing some of the simple programs like word count in traditional MapReduce. So it took 16 seconds for us. So when you have Spark running on a DFS, right, just not even a second, right? So I can able to see this or show you this demo. So now let me just show you this Spark running. For this simple quick example demo, I'm just using a file called readme.md, right? So I'll just run through. I have set everything ready for my time in searching processing, right? So now this is small exercise. We all know how to process Hadoop. The same file, readme file, I will do a word count program using Hadoop traditional MapReduce way. And then I will also show you if I do the same program using Spark. You see here, it is a Spark code, right? So how fast it is, right? Definitely you will appreciate. So to run Hadoop, I hope all of you know, right? Hadoop jar file, the Hadoop jar, then jar file name, input path, output directory path you need to give, right? So now let me give this here. So this is a simple MapReduce way. So now Hadoop jar, this is where we have the jar file that is in the one more directory practical. I have this jar file and then I'm reading this readme and then this is the output directory. Let me process this Hadoop using simple Hadoop jar. Word count program, right? So basically you need to write mappers, reducers, and then you need to create a jar file out of it. So, and then you can process this way, right? Now, if you see, it takes some time, right? So let us see how much time it takes. So it has processed, right? So now, if you come here, you can go to cluster, right? These are the processes, latest processes. So you can also type localhost 8080 here, and then you just come here and click on this IDs. This is the cluster metrics. Now you can see total time taken is 20 seconds, right? So now let us switch back, right? So now if I see same code processing, same data I mean to see, right? See now I am processing the same data, readme, right? By default, it looks as user Edureka, right? So that's why I don't need to give path. So let me copy this and then run here at this Scala. I have installed this Scala everything on this machine, right? That is Spark on basic Spark on this Hadoop, right? So now if I say it's as good as I'm referencing this file, right, at runtime. So now I've loaded this file, so I can run this word count this way. I can say save as test file this. So this way you will be writing your word count programs itself. Can you see how quick it was? This is the time, right? So I just wanted to show you how quick it is really, right? It's really quick, right? Same, but output never difference. I mean, there won't be any difference in the outputs, right? You can go to the respective directories where you have given output directories as far as mappers, traditional MapReduce or the Scala, everything output will be stored on SDFS itself. You can go and check in the respective folders. You will have the same result, I mean to say, right? So, but time we could able to see what is the major difference, right? So that's where we had this way. So now let us go ahead and see. One more thing is Cassandra, right? When I say Cassandra, I also refer in general this NoSQL. I'm referring in general NoSQL databases, right? When you hear NoSQL databases, it adheres to CAP theorem, right? Consistency, availability, partition tolerance, right? So this NoSQL databases, right, provides lot of features like maintaining sparse data. Sparse data means lot of data not being filled, and they are distributed database itself. They can manage multi-dimensional data. Multi-dimensional data. That too in NoSQL we say hash map of hash map of hash map. Data management, when it comes, it can manage multi-dimensional data. And all these databases, whether it is Cassandra, HBase, they all store the data as it's in a sorted manner, right? Also does sharding, automatic sharding, that is splitting and distributing of the data across multiple machines, sharding. These are the features, right? So though we say difference itself, all these features again provided by, if you see Cassandra and HBase both it provides. So Cassandra we say more towards availability, and HBase we say more towards consistency model. So as far as Hadoop and Cassandra itself, if you see, we say offline versus online. Hadoop, we all know batch analysis of unstructured or semi-structured data, but Cassandra, we can do online processing. When I say online, right, it is fast random access we can do using Cassandra. Row level updates, deletes we can do using Cassandra. In fact, using HBase also, right? So Hadoop integration was added in old as 0.6 version itself in Cassandra. So it has a native support for Pig, Hive, right? So it uses same interface as SDFS to achieve input data locality. I hope Hadoop means, we recall Hadoop means data locality optimization, what it does, right? Means it takes processes to the data, near to the data. Again, Cassandra also uses same interfaces as SDFS. So here we can have different ways of managing or marrying Hadoop and Cassandra together. One of the model industry practices is this standalone model. So we can have a different clusters of Hadoop, right? So sorry, different clusters of Hadoop, different environment for Cassandra, right? So if Hadoop requires some information from Cassandra for analytics, it can do it. Or you want some quick run on a online data store using Hadoop cluster from Cassandra, you can do it. So standalone independent clusters, existing Cassandra and Hadoop platforms can integrate. They can be different environments. They can be different business units itself. This gives good advantage and exposed to B2B consumptions, right? We can also go for hybrid model. If you see this diagram, so some of the nodes, only Cassandra nodes, some of them integrated with job trackers, some of them running including task tracker, right? So we can have a single cluster where we can have few nodes for Cassandra, few nodes as Hadoop plus Cassandra nodes, right? So that is single and hybrid cluster, shared infrastructure. Here also we say no SPOF because of storage model of Cassandra. Storage model itself of Cassandra, right? Sorry. So one more model, that is all-in-all overlap model also we can use. That is single cluster to run Hadoop and Cassandra. We can run analytics and real-time queries in all nodes. Right? So these are industrial best practices probably where we can look at, right? And Cassandra integration, I mean to say basically NoSQL itself. You can take it as instead of just Cassandra. Definitely, I hope all of you understand, right? Now we have, if you see NoSQL landscape itself, we have different kinds, more than 150 NoSQL databases itself, based on the types of the data, how they manage, right? So, and in CAP model, that is consistency, availability, partition tolerance, which guarantees they provide. Based on this, these NoSQL databases have been divided, right? So now, when I say this for an application, right? Some, I mean, enterprise applications when you are developing nowadays, we don't look at single database. I mean to say, when I am using Cassandra, it doesn't mean I am not using MongoDB. Right, based on the need, right? We might use nowadays. We might look at using multiple databases itself. One example I'll give, like a speculative retail web application may manage, we can say, product catalogs in MongoDB, user sessions in Redis, shopping cart in React, recommendations it can do by using Neo4j. Analytics it can do by using Cassandra or HBase, right? All this I have mentioned are NoSQL databases, right? And reports and financial data, transaction management itself, if you see, RDBMS best suits, right? So as I said, now speculative, this retail web application itself can use all these databases together itself, right? So now integration of Hadoop with Cassandra gave a remarkable performance for business improvements in companies using big data. So it also supports MapReduce, Big Hive, Woozy. Woozy is a workflow scheduler. We can also use it as a scheduler of these jobs, MapReduce. All this stack, right? MapReduce, Big Hive, these are stacks, processing environments, basically work as a batch processing, right? Also, we have Cassandra to do online, Cassandra, HBase, all these NoSQLs to do real-time kind of a processing, right? Together, Hadoop with Cassandra helps us to process, manage big data easily. So you will see more and more improvements in terms of marriage, in these marriages, right? These kind of integrations, I can say. Now, Pentaho, all of us know, right? Pentaho provides Pentaho Business Analytics, a suite of BI, business intelligence, right? Which provides data integration, OLAP, dashboarding, ETL, lots and lots of features, right? From data preparation and configuration to predictive analysis, Pentaho covers the data lifecycle from end to end with a complete solution, right? So this provides, that is, this Pentaho Business Analytics provides Hadoop users with a visual development tools, which makes easy prepare, model, visualize, and explore data sets, right? Pentaho is distributing big data plugin along with standard products only for Hadoop. Plugin, when I say to integrate with Hadoop, it is now living with standard products itself. So Hadoop configuration with PDAs are just collections of Hadoop libraries required to communicate with specific versions of Hadoop, right? And related tools such as Hive, HBase, Scoop, Pig. That means you can integrate with any processing tool here, right? So as I said, Scoop, you can use import and export of RDBMS data to big data, right? So HBase, you can do row level updates, deletes, and fast random seeks. Hive, Pig, batch processing on top of Hadoop data, right? So now Hadoop distribution configuration can be found at this, and PDA supports all these versions, right? So features, one of the bigger, good features of PDA is Pentaho data integration. Pentaho is, it gives a graphical ETL, and it gives a visual interface to call custom code, we can say. It has integrated debugger for testing, tuning, right? And also it supports native integration with Storm and Yarn, Pentaho, which enables developers to process this big data analytics in real time. That is the beauty, right? So MapReduce can return in traditional languages like Java, but needs that have a specific skill set, but needs to have this skill set, right? Not only skill set, you may have to write lots and lots of code. It may take a lot of time, right? PDA can be more powerful alternative to create MapReduce jobs with minimal technical skill and speed, right? With the speed, development time, I mean to say. When compared to traditional coding style, ETL approaches Pentaho visual development tools reduce the time to design, develop, deploy Hadoop analytics, right? For customers to be future-proofed, right? From this kind of rapid pace of innovations in big data environment, these kind of integrations are very, very important. And we will see this from almost all the softwares, products, and tools. In coming year, definitely you will see from almost all the products and tools available, right? And need also is not simple, right? Any vertical you mention it, we are looking at now real-time analytics, be it a financial, retail, telecom, manufacturing, healthcare, oil, public, transportation, right? So all these are some of the use cases where we need real-time analytics, right? Now, it's not easy to keep up with this kind of rapid pace of technology innovations, right? That is happening in this space. Very, really difficult, right? But however, there are certain high-level architecture constructs, right, that can help us maybe to visualize and prepare what we have to do next, right? So Lambda architecture is a useful framework to think about designing big data applications, right? So in what is there in Lambda, let me quickly review, right? So now, sorry. When we look at enterprise applications, right, we want to make sure that it supports both for batch as well as latency, low latency, right? Many times we would have asked ourselves, right, do you want to do OLTP or OLAP, OLAP, OLTP? Many times we would have asked, right? It's all about use cases and trade-offs, right? But Lambda architecture combines this slow and fast lane of data processing to achieve best of both. That is the beauty, right? So in Lambda architecture, we have three main major components, I can say, right? Batch layer, service layer, speed layer, right? So this batch layer, what it does is it manages the master data. Manages master data means raw incoming, raw data, that is historical data. It is immutable and append only set of raw data. All data entering into the system is dispatched to both batch layer and speed layer for processing. And this batch layer manages two things. That is managing of the master data with pre-computing, we say, to get batch views, we say. It provides facility to pre-compute with arbitrary functions, we say, and we get batch views on top of this data. Right? So that is, yes, I hope I have here. So batch layer has two functions: managing master data sets, that is immutable and append only of raw data, and pre-compute batch views. Right? And this service layer, right, indexes these batch views so that you can view or query with low latency. That's what this service layer provides us. It indexes this batch views. And this speed layer, right, this layer accommodates all these requests that are subject to low latency requirements. Right? Speed layer compensates for high latency, okay, for high latency updates to the serving to the layer and deals with the recent data only. So data goes to two places. One is speed layer, one is batch layer, right? So now querying, if you want batch kind of a view, that too with low latency, little low latency, I can say that is here. You want real time, you can see here, right? And I hope we have little more time. So we can realize these layers with various Hadoop technologies itself. Let me explain this. Now batch layer, right? We all know SDFS plus MapReduce to prepare. We can use SDFS plus MapReduce to prepare views, right? That can be fed to the service layer, right? Where service layer can be implemented using maybe NoSQL technologies such as HBase, Cassandra. And while querying can be implemented by technologies like Apache Drill or Impala. Right? And as far as speed layer is concerned, this can be realized with data streaming technologies such as Apache Storm or Spark streaming itself. Right? So I hope slowly you are understanding now. So that's what I said. We can realize these layers with various technologies, and then we can materialize this Lambda architecture. That is, you can use it for both, whether you need batch or as well as real-time processing, right? So there are a lot of tools, new upcoming tools. So Apache Tez, Accumulo, right? Tez basically provides pre-warmed containers, we call it as, for low latency dispatch. That means avoid lots of disk writes and fasten the query. Nowadays, Pig Hive can be easily implemented on things, right? So Accumulo, high performance data storage and retrieval system. Kafka, log service. Basically, it provides a functionality of messaging system, right? Nutch web crawler, Knox, authentication and access control, right? S4 basically fills the gap between complex proprietary systems and batch-oriented open source computing platforms. S4. There will be lots and lots of tools you will see definitely in 2015, right? So good things this Christmas at Edureka, right? Also we have a lot of lot of buy one to one offers, you can say, right? So now I hope really all of you enjoyed Hadoop 2015, right? So thanks for being with me. If you have any queries, please you can share with me, right? So maybe because of time restrict, maybe some of the queries which you see unanswered now, right? I will take it definitely offline. Maybe maximum by mid of tomorrow you should get all the mails, I mean to say, answers. Maybe because of some time restrict, I will also do all these questions. If it is too many questions, right, I will take up offline also. You don't have to be disappointed. So thank you for being with us. Thank you very much.
Thank you, Tejas. Thank you for the insightful presentation. Let's quickly take up the questions now. I would request you to read out the questions and their answers so that all our listeners may listen to your commendable insights.
True. Perfect. So Jiti says, how can we make use of Hadoop for analysis? Right, rightly, as I said, nowadays, as I said, integration tool itself, if you see, say simple take example of R analytics, right? R itself comes with integration tool of Hadoop. Very simple answer, right? You can write traditional R programming and use R integration on top of Hadoop itself. Or best is machine learning tools like Mouth itself to analyze, right? Jinesh, is that answer your question? So what can be the best combination for Hadoop developer having a Java background? I suggest, right, again, in fact, there was a time limitations. Otherwise, definitely I would have told you, I would have shown you how, if you know Spring, right, how easily we can integrate to Hadoop. Basically, that was my plan. Because of time restrictions, I'm sorry I could not show. But anyway, see now you write web applications or applications you can integrate as a data, or you can use Hadoop itself as a data store. Point number one. Right, and if you want to learn in Hadoop space, right, I suggest maybe you get into some of the NoSQL development itself, like HBase, right? If you are good at Java, right? So now this HBase kind of environment, NoSQL databases, they give Java API itself to process the data, right? So that will be really nice. And you can also, right, as I said, the next step of Hadoop, like when you start analyzing the data, right, you can definitely, as a developer, so you can easily learn Mahout or anything, right? Mahout, all Java related technology, but that is the advantage of Hadoop developers, as you see, right? And if you are very good at core Hadoop Java, right, core Java, right? So you can also contribute or think of development of products itself, value-added product itself to Hadoop, probably. So you said there will be a lot of demand for this tool. Do you feel professional who don't have any experience in this will be able to pick up this? Probably, Girish, as I said, that's where I said I have spoken about multiple components here, right? So probably you can think of, if you feel like if you are new or anything, so you can just use like Pentaho tools, right? Pentaho gives, you don't need to be skilled person for it, Girish. So now you can use integrated tools like Pentaho and then straight away start looking at learning and then processing Hadoop data. And basic, one more thing is, if you know simple SQL, right, so you can analyze the data. That's what is the future. In the presentation also I told, right, nowadays everybody wants to look, right, so all companies will demand SQL for all reasons. So you don't have to be technical savvy, right? So SQL queries to run, basic SQL, if you know, you can definitely analyze the data. You don't have to be programmer for it, right? I'm working on PDA, how to integrate with the PDA. Pentaho itself comes with a data integration tool. Very simple it is, Sanjay. Very, very simple. I'm sure you can download today and then learn it, right? I'm really sure. So how Microsoft SQL Server developer can proceed is career in big data. Narendra, as I said, if you know SQL Server, right, you know all SQL queries, right? That is good enough. Best the data flows and then how Hadoop itself works. Maybe it takes a little time to learn. So maybe you can use Hadoop as a data source and use SQL queries itself to analyze the data. There are a lot of tools like Hive, right? Hive, Impala, like they all use. So now Shark or I said Spark SQL, right? They all use simple SQL based queries itself, Narendra. Right? So what are the technologies DBA can pick, carrier, big data? That's what. Manish, I hope this answered your query also, right? What are the tools, right? I hope this answered your query, right? So can we expect Hadoop jobs for freshers? see, it depends on requirements, right? So companies, so fresher, I mean, so I also suggest, please, you have to at least learn the environment, right? Technology environment. You cannot just expect the companies to give on training, right? So definitely, if you, instead of until unless you need to work, right? So definitely, if you learn, there will be definitely possibilities, right? As far as freshers, yes, you may get. It depends on type of jobs. So now definitely, right? In Hadoop space, yes, it is like a simple normal technology. So now where you may, a lot of newcomer also get chance, right? It is as good as here. You don't have to be experienced, but anyway, it depends on job, and then projects which the companies are working with, right? So some of the companies, right, they may take and then train you also, right? So as I said, Python, right? So now a lot of companies, they have started using Python itself, right? So some of the companies, I have heard probably through support team, I think you can mail to Edureka support team, we can also help you in that. So a lot of companies, they take train on Pythons and then they place you. Maybe many projects on Hadoop itself. Can you share some of the resources for Hadoop learning? Definitely, I would love to do, Mangesh. Probably you all have to write a mail, right? So please, probably feel free to write, ask Edureka for queries or support. I think these are the queries, right? You please write to us. Definitely, we'll love to do that. Give all resources, right? You don't have to be, you don't have to worry. Definitely, we'll love to do that. So I am a Java developer almost 9 years, definitely, that's what I was telling. So now, though you have 9 years experience, still you are thinking about Hadoop, right? Probably nowadays, you Hadoop, all the companies, right? Majority of the companies, now data, if it is big or unmanageable, definitely we move it onto Hadoop itself, right? When I say that, Hadoop, it is becoming like a de facto standard for storage and processing of data, right? So now when I say that, you will have a lot of opportunities, be analyzing the data or streaming and processing the data, right? Definitely, right? All the companies moving Hadoop to Yarn using tools like R, Spark, which NoSQL, best database best. It depends again based on use cases and then companies itself. So I told you, right, which maybe one best example what I discussed was retailer web application, right? Databases itself is not fixed, definitely. Well, I told you some of the use cases like Redis, MongoDB, React, Neo4j can be used in a single application, right? Analytics, Cassandra HPS can do, RDBMS, financial processing can do, right? So like this. So now, but this Spark, right, comes with multiple tools itself nowadays. So that's where we started with Spark, because Spark, you see, it is becoming like again multiple processing environment on top of Hadoop. So it and with speed, that is the value added advantage, right? Coming back to R is like an analytical tool, Sandeep. R is statistical analytical tool, right? So thank you very much, friends. If I have not answered, definitely mail to this, ask us. I will keep in touch. Definitely, I will love to answer all of your queries. Thank you very much for all of your cooperation, friends. Thank you very much. I hope this was really helpful. Thank you and good luck and success to all of you, friends. And wish you all very happy New Year. I wanted to end this session. Thank you very much. Good luck to all of you, friends.
Thank you, Tejas. I'm really thankful to our guest speaker for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on techgeek.com very soon. Thank you, everyone.
Thank you very much. You're welcome. Thanks. Bye-bye.